Vipin. Today we are going to discuss an important topic in signals and system, that is types of signals or classification of signals. The first classification is the periodic signal. What do you mean by periodic signal? Periodic signal is a signal in which the signal repeats its instantaneous amplitude after every constant period. I will explain you with a narrative of an example. That consider a wall fan that that you have in your home. Consider its extreme left position is the initial position, and it is t is equal to 0. When you switch on the fan, the fan starts to rotate from the extreme left position towards the right, and then back to its initial position where it was initially. Then after that time, it happens to repeat the same rotation that you had in the first. Such kind was in that case we call that fan as periodic. Similarly, we can say a signal which is periodic, it will repeat after every constant period of time. So we call the capital T as the time period. So when for a continuous time signal, x of t is said to be periodic if and only if it will repeat after every positive value of time period. So we can write it as x of t is equal to x of t plus capital T. Is continuous time signal satisfying this condition is said to be periodic. Otherwise, it is aperiodic. For example, if we consider a signal sine omega 0 t, then let it be x of t. Then to find it is periodic or not, we have to find x of t plus t. If we get the same x of t, then sine omega 0 t will be periodic. So for x of t plus capital T, we will get sine omega 0 t plus capital T, which is equal to sine omega 0 t plus omega 0 capital T. This sine omega 0 t plus sine omega 0 capital T will be equal to sine omega 0 t only if when this omega 0 t will be is equal to 2 pi. So we can say the signal with this kind of periodic signal or this kind of sinusoidal signal will be periodic if and only if omega 0 t is equal to 2 pi. So we can say here the time period will be 2 pi by omega 0. For this condition with period this capital T, this signal will become sine omega 0 t. So this will be same as the x of t. So we can call this kind of signal as periodic signal. We can consider the discrete time signal x of n. A discrete time signal can also be periodic if x of n is equal to x of n plus capital N. That means x of n should be periodic for every capital N with period capital N, and it should be positive. Here the similar condition as in the continuous time periodic signal. Here discrete time signal also satisfies the same condition. So if we consider such a sinusoidal signal as sine omega 0 n, to find it is periodic, we have to consider this condition. That means in RHS x of n plus capital N is equal to sine omega 0 n plus capital N, which becomes sine omega 0 n plus omega 0 capital N. And this will be, and this equation gives the sine omega 0 n if and only if this omega 0 capital N will be a multiple of 2 pi. will be multiple of 2 pi. So here we have to consider n as an integer, also m will be also an integer. We can't consider any decimal values or irrational numbers for m or n. So here we can say this kind of sinusoidal signal will be periodic if and only if capital N is equal to 2 pi by omega 0 into m. For this condition, the signal becomes sine omega 0 n, same as the initial signal x of n. So here we can say the signal is periodic. Here we have two conditions, x of t is equal to x of t plus t for continuous time signal, and x of n is equal to x of n plus capital N for discrete time signal. And here we can consider the smallest value of t is called the fundamental period of the signal, and the smallest value of n is called the fundamental period of discrete time signal. So you have to take note of these two things because in exams the question will be asked to find the fundamental period of the corresponding signal. Another important kind of signal is even and odd signal. Sometimes it is also known as even as symmetric and odd as anti-symmetric. Basically, even a continuous time signal x of t is said to be even or symmetric if and only if when minus t is equal to x of t, then the signal should be symmetric or even. In the same case for discrete time signal, that is x of minus n gives x of n, then the signal will be even or symmetric. Here we have to understand that x of minus t and x of minus n gives the reversed signal, that is it is the time reversal of the original signal. If we reverse the original signal and we get the same signal as x of t, then it is even or symmetric signal, otherwise it is anti-symmetric. For example, consider a signal like this. Signal like this. Here we can see we have if we even reverse the time from positive side to negative side or negative side to positive side, that means it is t and x of t. If we take x of minus t, we will get the same signal like this only. So these kind of signals are called even signals. And for odd signal we have the condition like x of minus t, which gives minus x of t, and for the discrete time signal x of minus n, if it gives minus x of n. These both condition represents the anti-symmetric signal or the odd signal. We have another example. We have to consider another example for this, like if this type of signal is x of t, and if we reverse the signal or take x of minus t, then we get only minus x of t. Since if we reverse this signal, this half comes to this side and this half comes to this side, that is equal to minus x of t. And so these kind of signals is known as odd signal or anti-symmetric signals. So for symmetric signals, we have examples like cosine signals, so cos t. And for anti-symmetric signals, we have examples like sin t, like that. Another classification of the signal is causal or non-causal signals. Causal or non-causal signal. A signal x of t is said to be causal if and only if it is equal to 0 for t less than 0. If the signal x of t is 0 for t less than 0, then it is said to be causal. Otherwise, it is known as non-causal. That means if the signal x of t have values in the both sides, for example in t greater than equal to 0 and t less than 0, such kind of signals are known as non-causal signals. And the signal which is 0 for t less than 0 or no values for the negative values of time, such kind of signals are known as causal signals. When we refer some text, we can also see anti-causal signals, which means the signal like x of t have only value for t less than 0, that is, it is 0 for t greater than equal to 0. Such kind of signals are known as anti-causal signals. So that's all for today. Kindly stay tuned to my channel for these kind of videos. Thank you.